Hello friends, happy morning. Myself Reshma welcomes you to the next session of database management system, that is data modeling using entity relationship model. In previous session I have discussed about the concept of data model and also different type of data models. So now here in this session we will concentrate on entity relationship model. So before starting ER model, just I will refresh the meaning of the data modeling concept. So these data models, these are the fundamental entities which are used to introduce abstraction concept in DBMS. And these data models, they define how the logical structure of database is modeled. So now to define this logical structure, data modeling concept, it has a different type of data models. Among those, one of the best conceptual data model is the entity relationship model. So now this entity relationship model, so this describes the structure of the database with the help of a diagram, and this diagram gives the relationship between the entities which are used in this diagram. So this diagram, it gives the blueprint of the database. Just like before constructing a building, as we are designing the blueprint for that building, and based, if the blueprint is best, then the building will come out with the best structure. In the same way, if we have a very good blueprint for the database, then we can design a very good database. So now for the design or implementation of the database, first we need to have a blueprint, so that we can have with the help of ER diagram. So now here, if you go for ER diagram, the main components of the main components of ER model or entity set, their attributes and relationship among those entities. So we can define ER diagram as a diagram which shows relationship among entity sets. So here entity set means a group of similar entities, and all these entities can have same attributes. Such a collection of entities is referred to as an entity set. And this collection of entity sets with their attributes, it will give us a complete logical structure of database in the form of an ER diagram. So now we'll learn each and every component of the ER diagram in detail. So that is, it mainly describes entities, attributes and relationships. So these are the components category, mainly three types, three components: entity, attribute and relationship. Again, entities can be categorized as weak entity and strong entity. We will categorize based on the values of the attribute. We have different types, and based on association between one entity to another type, we have mainly four type of relationships. So now we'll study each of these components in detail. So as we said, ER diagram is the diagrammatical representation. Each component will be indicated with a different symbol. Entity using a rectangle symbol, attribute an oval, relationship a rhombus or a diamond. Then these are the special type of entities and relationship. So This is a double rectangle to indicate weak entity type, multi-valued with double line vowel, and weak relationship with double line rhombus. So now we'll see what is the meaning of weak entity type, multi-valued, weak relationship. All these we'll study here. So these are the different symbols. So once I will finish all these type of attributes, so then we'll refresh with these symbols. So let's start with an entity. So entity is a real world object which has a physical existence or a conceptual existence. For example, a student. Student is a physical real-time object which has its own properties like name of the student, USN for the student, age of the student, to which department he belongs to, in which semester he is studying, which course he has taken, how much marks he has got. So like this, if I take a student as an object of the real world, which has these so many properties, and we can call such objects as an entity. And the properties of such entities are referred to as attributes. And based on the property value, the attributes are categorized into different types. They are composite versus simple attributes, single valued or multi-valued attributes, stored and derived attributes, or attributes with the null values. So now we'll see one by one here. The composite attribute versus simple. So simple or atomic attributes are the attributes whose value cannot be divided further, which is already in its simplest form. They are referred to as simple or atomic attributes. So then composite attributes are the attributes that can be further divided into simple attributes. For example, if I take a name, so name can be divided into first name, middle initial or last name. Similarly, if I take an address, address can be divided into city, state, country, street number, home number, or apartment number. Like this, again, address can be divided into smaller components. So they are referred to as composite attributes. So now if I take a semester for a student, if student belongs to fifth semester, it is a single value, simple attribute. They can't divide the semester 5 into again sub parts. So the attribute value which cannot be divided further, which is already in its simplest form, is referred to as simple or atomic attribute. Now second category is single valued versus multi-valued. If an attribute can occupy only one value, that is referred to as single value. For example, a student USN number. One student can have only one USN number. He cannot have more than one USN number at a time. So, and again, a person can have only one Aadhaar card number. A person can have only one PAN card number. So such type of attributes are referred to as single valued attributes. If you go for multi-valued attribute, if I take a student can have n number of degrees. He might have done undergraduate, diploma, then he has done graduation with BE, then he will go for masters, then he will go for post graduation. So like this, a single student can have n number of degrees. Similarly, if I take a car can have different models. A car with a particular model can have different colors. That is a single attribute. It can have multiple values. So and again nowadays, a single person may have n number of phone numbers. He can have n number of mail IDs. So that they are referred to as multi-valued attributes. So the symbol used for simple attribute is oval. Multi-attribute we have to use double line oval. So the next is stored versus derived attributes. So stored attributes are the attributes which have their own value, but derived attributes are the attributes whose value can be extracted or derived from some base attributes or the stored attribute. For example, in this diagram, if I go for area, for a particular circle, with the help of radius, we can extract the area of that particular of a circle. If I take a circle, the circle will have its own value like radius or diameter. But if I want to get the new value like area of the circle, then I have to take the help of the stored value, that is radius, or stored value like pi value. So they are referred to as derived attributes. Similarly, if I want to find age of a person, I need to take the help of the stored value birth date. So birth date becomes stored value. With the help of the birth date, we can find age of the person. So now age of the person becomes a derived attribute, and derived attribute will be represented by dashed line oval. Simple are stored with a solid line, and that is single solid line oval. The next type is complex attributes. So now these complex attributes are the attributes which contains both composite attribute and multi-valued attribute. The combination of composite and multi-valued attribute is referred to as a composite attribute. So these are some of the attributes which are categorized based on their value. And sometimes we can have the attributes whose value is null. So means we cannot enter any value for some of the attributes. So the attribute may also occupy a null value. Again, to enter the null value, we can go with some different conditions, which we'll study again later. So, but just I will tell in brief, attribute can have null value in different condition. The first condition, if the value is missing, if the value is unknown or undefined, or if the value is not applicable. So in these cases, an attribute can have null value. So this is an example of a entity with their attributes. So here student is an entity which have attributes like student name, simple attribute, age, derived attribute, date of birth, stored attribute, student phone number, multi-valued attribute, and student ID. So which is a key attribute which will be the unique for each student. So now entity type. So now entity type is an entity which has similar attributes. So now entity set means the similar attributes of those entity types are referred to as entity set. Okay, so entity type is a collection, or entity type is that collection of entities which are having similar attributes. Like if I take an employee entity type, then all employees in the employee entity type should have same properties like name, age, and salary. If I want to define student entity type, then we have to include all the entities with similar attributes like USN number of the student, name of the student, semester, department. So like this, we have to define entities with similar attributes, and those values are referred to as entity set, and the set of entities are referred to as entity type. So then next is key attributes of an entity type. From the different properties of an entity type, there are some special properties, special attributes which are used to find uniqueness property of that particular entity, which are used to identify the entity uniquely. Such type of attributes are referred to as key or unique constraints attributes. For example, if we take student entity type, a student will be uniquely identified with the help of university seat number, that is USN. And the symbolic representation of key attribute is same as solid line oval, and name of that attribute should be underlined with a solid line. So underline with solid line, the attribute indicates as a key attribute. So now here for student we have given roll number as the key attributes. Name and age are not, because name and age may be repeated. Two students may have same name and they may have same age, but more than one student cannot have same roll number, which is a unique key. So now, based on this key attribute, the presence or absence of this key attribute, entity types are categorized as strong entity type and weak entity type. So strong entity type is an entity type which contains the unique key. For example, if I take an employee, employee will be identified by unique key SSN, Social Security number. Hence, we can say employee as a strong entity type. Similarly, student will be identified by his USN. Student also behaves as a strong entity type. And the symbol used to indicate strong entity type is a single lined rectangle. Then weak entity types, other entity types which are not having key attributes. So means we cannot identify those entity types uniquely by their own. To identify those weak entity types, we need to take the help of strong entity types. So the entity types which cannot be identified by themselves with key attributes, with their own key attributes. So because the key attributes is absent in those entity types, and they are weak entity types. For example, dependent. A person, an employee dependent on some employees are referred to as are the weak entity types because they cannot be identified by their own SSN. There is no social security number for all the people like the dependents. They should be identified by the employee, so they are referred to as weak entity types where key attribute is absent, and it will be indicated by double lined rectangle. So next is composite key. So now we have seen key is an attribute which is used to identify an entity type uniquely. To find the uniqueness of an entity type, we have used a key attribute. So now there are some entity types which may have more than one attribute as a key. If you have more than one attribute as a key in some entity type, then such set of key attributes are referred to as composite keys. For example, if I take a car entity type, then to identify the car uniquely, registration number and vehicle ID. So both are unique here. Registration number for each car is unique and vehicle ID is also unique. We can identify car uniquely with the help of these two key attributes. Now the combination of these two key attributes is referred to as composite key. So now we have studied different type meaning of entity types, what are the attributes, types of attributes, strong entity type and weak entity type. So now we need to form an association between one entity type to another entity type. Then to form this association, we need to make use of different type of constraints. So now here we will study what mean by these association, what are the constraints, how to form the association between the entity types. So let's start with the relationship type. So now here we have two types of entity types, employee and department. Between employee and department, so there is an association, like employee works for the department. So now here works for is the association between these two entity types, and it is referred to as a relationship type. So relationship type is an association between two or more entity types. So here works for is a relationship between employee and department. Now relationship instance. So relationship instance indicate the association of each entity with entity of another entity type. For example, here employee E1 works for department D1 at this moment of time. So now we can say E1 relate to D1 is one instance of the relationship works for. Similarly, E2 works for department D2. Then employee E2 and E4, they works for department D2. Such type of examples are current states of the relationship are referred to as relationship instances. It show the number of employees in one entity type works for different departments. Again, this association may be referred, instance may be referred in terms of number of employees work for the department, or how many are, so how they are works for the department. So based on this, again, we'll categorize in relationship instance in different ways later. So this is an instance. So each instance indicate an entity works for, employee entity works for some particular department. So now based on the number of entity types involved in this association, we can define degree of the relationship. So degree of the relationship becomes 2 if the number of entity types involved 2. So now here in works for relationship, we have two entity types. One is employee and another is department. So this relationship is between two entity types. So that is referred to as binary. Similarly, if we have three entity types which is connected with one association, one relationship, then that will be referred to as ternary. So now here supply is a ternary relationship, so which connects supplier, part and project. That is here how to define the instance here. Supplier S1 supply part P1 to the project J1. Similarly, supplier S1 supplies part P2 to the project J1, J2 and J3. So like this, association is defined for three entity types. So it is referred to as ternary relationships. So which gives the degree. So degree of relationship is the number of entity types involved in the relationship. The next is the role name. So here, after defining the relationship, forming an association between two entity types, while defining the instance, we can define what is the role of each entity type in that association. For example, here, employee works for the department. On which role he is working, whether the employee works as just an employee, or whether he is manager of that department, or whether he is supervising some employees in the department. That is here, role defines the purpose or what are the activities or the task that particular entity type is doing when they are associated with other entity types. So here managers shows that employee's role is the manager. So then next type of relationship is recursive relationship or self-referencing relationship. So now till now we have seen the relationship between two different entity types, between employee and then department. Similarly, we can have employee works for some project. Their employee is different and project is different entity types. So now sometimes we can have association between entity of one entity type to entity of same entity type. So such type of association are referred to as recursive relationship or self-referencing relationship. So now for example here, employee E1 related to another employee as a supervisor. Like employee E1 is the supervisor for other employees in the entity type employee. So here E1 is an supervisor for E5. E2 is supervisor for E1. So that is here entity of employee entity type relate with another entity of same employee entity type. So such type of relationships are referred to as self-referencing relationship. For example, if you consider your class, a student may be the class representative of the class. So one student will be monitoring other student in the same class. So that is the same relationship between student of one class to the student of the same class. So that is referred to as recursion. So then while defining the relationships, here also we can make use of some conditions. So that is the constraints on binary relationship. So mainly here we have two type of constraints. One is cardinality constraint and second one participation constraints. Now cardinality constraints indicate the number of instances of one entity type relate to how many number of instances with the second entity type. So based on that, here we have mainly four types: 1:1, 1:n, n:1, and m:n. So now here we'll just see the diagrammatical representation here. 1:1 means only one employee can manage one department. We cannot have more than one employee as manager of some particular department, and at the same time more than one department cannot have one manager, or more than one employee cannot manage single department. So means one employee can manage only one department. N employees, more than one employee cannot be the manager for one department, or more than one department can't have one employee as the manager. Such type of constraints can be indicated with the help of 1:1 relationship. Now 1:n. Can you guess what will be the where we can form 1:n relationship? If I take between employee and project, one employee can works on n number of projects. Okay, so that is 1:n. n:1. See, dependent, 10 people can depend on one employee. Okay, or n people can work on one project. As one n people can work on one project, one person can also work on n number of projects. Then m:n. If I take same employee and project here also, m people, m employee, any number of employees can work on any number of projects. Okay, so this is the cardinality constraints on the relationship indicate the number of entities from one entity type relates to the number of entities in another entity type. So this is the cardinality constraints. So then next is the participation constraints. Then what will be the meaning of participation constraints? So now here this indicates the number of instances of an entity that can participate. So the participation constraints, it defines, so don't get confused with the cardinality constraints and participation constraints here. So participation constraints defines the minimum number of relationship instances of one entity relate with another entity. So we can say participation constraint, it define the least number, the minimum number of relationship instances in which entity must compulsorily participate. What is that minimum number of instance? So based on the minimum or the how many instances are compulsorily participating in the relationship, based on that here we have total participation and partial participation. So now if we go for total participation, so in total participation here it specifies every entity in the entity set must compulsorily participate in at least one instance of that particular relationship, right? So then as every entity must participate compulsorily, mandatorily, then it says a total participation. So now if we take employee works for department, can we have any of the employee who cannot work for the department? No, it is not possible. If he is an employee, he must work for at least one department. He must work for some department. So every instance of employee must work for some department. So everyone has participated mandatorily. So this is referred as total participation. Total participation means all instances, the total instances, complete instance of an entity type must participate in the relationship. So it is total participation. And partial, again in ER diagram, so we have to use double line between relationship type and entity type for total participation. But if we go for partial participation, so now this specifies the entity type in one of the entities set. It may or may not participate in the relationship. If it participate, only some of the entities in an entity type may participate. Here it is not mandatory, it is not compulsory for all the entities to participate in the relationship. So this is optional. So this is optional for the employees. So for example here, employee manages the department. Whether all employees will behave as manager for the department? No, only some employees may be the manager for the department. If I consider the college, only so if a college may have some 500 employees and some 5 departments, whether all 100 employees will be the heads of those departments? No. For example, employee 3 maybe head of some department D1, only employee 5 is the head of the department 3, employee 6 is department of 2. Other employees they are not head of the department, they are not managing the department. So this is optional for those employees. If it is mandatory for all, that becomes total participation. If it is optional, then that will become the partial participation. Then the symbol used for partial participation in ER diagram is a single line between entity type and the relationship type. Okay, so this is about the partial participation. So then we can form a relationship between, again, so the partial participation and that is the participation constraint and cardinality constraint. So if the cardinality, so based on the minimum cardinality constraint, we can decide whether the participation is partial or total. If the minimal cardinality constraint value is 0, then the participation constraint indicate it is a partial participation. And if the minimum cardinality is 1, then it signifies, it indicates the participation constraint is total participation. Okay, and then if we consider maximum cardinality constraint, this maximum cardinality, it will always tells maximum number of entities that participates in the relationship type. So this is about the relationship types based on the number of participants as binary and ternary, number of entity types, binary, ternary, based on number of instances involved in the participation, whether this is mandatory or compulsory. Based on that we have total and partial, and based on how many are participating we have cardinality constraints. So these are the symbols which we have to use in your diagram for relationship. So these symbols I have already showed at the beginning. So relationship rhombus, identifying relationship, so which is used to identify weak entity type from strong entity type, that is double line rhombus. Then total participation is between here R and E2. I have total participation. It should be indicated with double line. If it is partial participation, so here between E1 and R, partial participation, single line. So cardinality constraints have to be placed towards each entity type. Then another feature of ER diagram is Attributes of relationship type. So till now we have seen we can have attributes for entity types. For example, if I have an employee can have attributes like SSN of the employee, name of the employee, department of the employee, salary of the employee, and all. But now, between two entity types, we have defined the relationship, and those relationships may have some attributes. We'll see some example. What are the attributes we can have for relationship? So now here, between employee and department, I have a relationship. Managers, that is employee manages the department. So one of the employee is the manager of the department. So while joining the department, he might have joined as an employee, but with the progress, the employee might be promoted to the manager. So then the managers in relationship will get some attribute like when the employee has become the manager, what is the starting date of the manager? What is the start date of the employee when he started behaving as the manager? So now here start date is an attribute of a relationship type, not the entity types. Similarly, employee works on a project. For how many hours he is working on the project? Now this hours is an attribute of relationship type works on, not the employee or the project. Okay, so here we have given some examples of properties of in relationship type, that is attributes of the relationship type. So then weak entity type we have discussed. So the symbol is like this: employee strong entity type, dependent weak entity types. So relationship is double line, rhombus or diamond shape, which is called as identifying a relationship. Strong entity type, some examples here we have shown. Okay, between student and course. Strong entity type, total participation, this is partial participation. So now by making use of all these components of ER diagram which we have studied till now, with the help of those we can design a blueprint for a company database, that is a conceptual design of a company database, so which can be summarized with this diagram here. So here we have an employee, the details of the employees are given, dependent, department, project. Okay, so now by making use of this we can design an ER diagram for a company database. We'll go for a basic structure of company database, then by using different terminologies again we will refine, and that I will discuss in the next session. So thank you for active participation here. If you have any doubts about the components of ER diagram, please share your suggestions and pass your questions in the comment box. And then now to the next section is examples of different ER diagrams for different databases. So we'll be discussing the next session. To get my next session, please subscribe to my channel, and to get the continuous updation, so click on the bell button. Thank you. Thank you for the subscription and watching.